Well, hello everyone, and welcome to today's webinar entitled Seeking Net Neutral Energy Efficiency in the U.S. Rice Industry. I'm Chris Boomsma, Director of Education here at the American Society of Agronomy, and it's my privilege today to co-moderate this presentation with Lydia Holmes of USA Rice, and we'll hear a little bit more from Lydia here shortly. Before we do so, first I want to acknowledge today's sponsor. Today's sponsor is the Rice Foundation and the USDA Natural Resources Conservation Service. Because of their sponsorship, this webinar comes to you free of charge. So we thank them very much for sponsorship today, bringing sound educational advice to you free of charge. Please note though that sponsorship of this webinar does not imply endorsement by the American Society of Agronomy. So keep that in mind. But again, thank you to today's sponsors. Now a few housekeeping items before I hand it over to Lydia. First, if you're having any issues, please contact Michelle Lovejoy. You can see her email address and phone number on your screen at this time, whether it be course content, registration, or something else technical. She will try to resolve your issue as quickly as possible. So again, please reach out to Michelle. Secondly, we will have a question and answer period at the end of today's webinar. So during this entire presentation, feel free to submit your questions using the questions portal built into GoToWebinar. Submit them, they come to me. I take a look at them, order them, consolidate them, and do whatever it takes to get them ready for presenting to our presenters at the end of the webinar. Third, please note that this training session is being recorded. It will be available to you about 1 week after completion of the presentation. You'll not only have access to the video and audio file, but also to the presentation slides. Lastly, be on the lookout for future webinars from the American Society of Agronomy in the coming months. And with that, I am going to turn it over to you, Lydia. Thank you so much for being the main moderator for today's presentation, and we look forward to hearing from the slate of speakers you've brought to us today. So with that, take it away, Lydia. Thank you very much.
Thanks, Chris, so much for having us on and giving us this opportunity. Give me just a second. We'll get these slides up. There we go. As Chris mentioned, I'm Lydia Holmes. I'm with USA Rice. We're the National Trade Association for the U.S. rice industry. I work primarily on sustainability and also with our members and working on a lot of these issues around efficiency and trying to do the best that we can to not only sustain our industry, but sustain the resources that we have. So I'm excited today to bring you all some really fantastic speakers. And first I'm going to tell you a little bit about this project. So the sustainability space is ever changing, and often as you get close to one goalpost, it moves. So as our industry has worked for years to think about continuous improvement and finding these efficiencies, we wanted to stop and take an accounting of where we've been. Rice farming and milling has changed a lot over the past 50 years, and we've really come a long way due to innovation and efficient practices. So in 2018, the Rice Foundation and NRCS released a report documenting the progress of the U.S. rice industry that we've made in the last generation on sustainability and conservation. It looked at a 36-year period between 1980 and 2015, and we were able to document how we're now producing more than we ever have while using considerably fewer resources like land, water, and energy. And you can see here some of those major reductions and improvements in efficiency. If you want to read the entire report, there's a QR code there in the corner. If you scan that with your phone's camera, you can actually go and see the full report if you're interested in learning more. So today we're specifically going to talk about reductions in energy use. But the cool part to me is that many of the energy efficiency practices are also saving water, they're reducing greenhouse gases, or both. Sustainability is all about finding those win-wins. So it's going to be pretty interesting, I hope, for you all to see some of all of these connections and how the pieces fit together. So while rice production increased from 1980 to 2015, energy use in the rice industry has decreased by about 34%. And there's a variety of efficiency practices that are achieving that, and they're not only achieving energy savings, but also cost savings. So today you're going to hear about a handful of those. Efficient equipment on farm and conversion of wells from gas to electric, more efficient drying and storage, adoption of solar power, and the creation of bioelectricity from a rice milling byproduct, rice hulls. So I hope all of this is very interesting for you guys. And so now I'll introduce you to our speakers. So first we have Fred Zonbrecher. He's a farmer from Rayne, Louisiana. He's a fifth-generation farmer who started working on his family farm at just 9 years old. He farms 4,500 acres of rice, soybeans, and crawfish with his two brothers. Their farm grows multiple U.S. rice varieties, including some that are a little bit newer and different, kind of fun things, some aromatic jasmine. They grow long grain and medium grain, as well as purple rice, which is something very unique to their operation. The Zonnebreckers are known for their interest in innovation, utilization of new technology, and collaboration with research scientists at the LSU Ag Center. Fred serves on multiple national boards and committees for the U.S. rice industry, including past chairman of the USA Rice Council and a longtime member of the Louisiana Rice Research Board, the Louisiana Rice Producers Group, and the Water Resource Commission. He's a graduate of the 2003 Rice Foundation Leadership Class and was named Farmer of the Year in 2006 by the International Rice Farmer and Rice Farming Magazine. Next, I have AJ Hood. He's a farmer from Tiller, Arkansas. AJ grew up in Southeast Arkansas and attended college at the University of Arkansas in Monticello, where he received a bachelor's degree in animal science. He received his master's in ag regulations from the University of Arkansas at Pine Bluff and has worked in various positions for the University of Arkansas in ag research and extension. AJ is a cotton, soybean, and corn farmer and manages several large farming operations in Southeast Arkansas, which include an ag flying service, fertilizer company, and grain storage business. AJ is the current president of the Arkansas Soybean Association, a member of the Arkansas Ag Council Board, and serves on the Drew County Farm Bureau Board of Directors. AJ is involved in the Miracle League of Southeast Arkansas, growing pumpkins to sell as an annual fundraiser, contributing to the league being able to raise enough funds to build an entirely handicap-accessible baseball field for children with disabilities that will serve an 8-county area in Southeast Arkansas. Next, we have Chris Crutchfield. He's the president and CEO of American Commodity Company in Williams, California. Chris Crutchfield is the president and CEO. He shortly after graduating from the University of Missouri in 1996, Chris moved back to California and joined with his father, Paul Crutchfield, in the formation of a rough rice pool for direct marketing to Turkey. Chris was responsible for the day-to-day management of the pool. That partnership developed into the American Commodity Company in 2000, and Chris assumed all direct management responsibilities for the company. Prior to establishing himself in the California rice industry, Chris worked in the offices of California Governor Pete Wilson as assistant press secretary. He also briefly taught secondary education in the California public school system. Chris is currently very active in multiple U.S. rice industry associations at both the state and national levels, including as a past chairman of the USA Rice Millers Association. Chris was a graduate of the 2003 Rice Leadership Class, and in 2018, ACC was chosen to receive the USA Rice Sustainability Award. Last but not least, we have Carl Kaiser. Carl is the plant manager of AgriElectric Power Partners and AgriElectric Research Co. in Lake Charles, Louisiana. Carl is the plant manager and has held the plant manager position at AgriElectric since 1996. He's been actively involved with power purchase agreements, technology agreements, and managed over 30 major projects. As the plant manager, he oversees daily operations, maintenance activities, capital projects, and regulatory compliance on federal and state levels. Mr. Kaiser also leads the R&D and product support teams by organizing production, sales, and product development for the byproducts division. He has an automation and controls technology background for over 35 years and has worked in electrical power and chemical manufacturing industries. So lots of very great speakers for you today. And without further ado, I will turn it over to Fred Zonnebrecker.
Thank you, Lydia. I appreciate it and glad being here. Today, I'm going to be discussing a few ways that our farm uses energy and has developed more efficient uses of that energy to enhance sustainability in the production and management practices of our rice crop. First slide, please. First, I'll be covering the conversion of diesel-powered water wells to electricity. Next slide, please. 14 of the 16 existing wells that we currently operate on electric motors, and they irrigate or flood about 2,000 acres annually. These wells range anywhere from 8 to 10 inches. We have a static water level of about 85 feet here in Louisiana. These pumps are two-stage pumps that produce probably a minimum of about 3,000 gallons a minute. We're sitting over the Chico Aquifer, which has been a good water source for us. The other two remaining power pumps remain on diesel because of the fact that they're in such a remote location that the cost of getting lines to those locations would be cost prohibitive, and actually attaining right-of-ways through multiple landowners is difficult also. Next slide, please. We started converting water wells to electricity in 2007, and I'm sure most of y'all remember that diesel prices at that time were a hot topic of conversation in a lot of the local coffee shops. Here you see what a conversion looks like with an existing gearhead and drive shaft. Basically, we just swapped the electric motor out for the diesel engine that was there. Next slide, please. Here we have a vertical direct drive motor that was probably used on a new well where there was not an existing gearhead or shaft. And the only drawback to a direct drive motor is if you don't want to produce the maximum output on the well, there's no way that you can reduce the shaft speed because it's directly driven to the pump. Next slide, please. If you remember, diesel prices peaked in July of 2008. I actually went back to our records and found out that we had paid actually $3.98 a gallon for fuel at that time. Our average fuel price during 2008 was about $3.50 a gallon. And with those power units burning from 5 to 8 gallons an hour, the daily range was from $420 to $670 a day. And we just couldn't see and continue to pay exuberant prices like that. We started converting to electric motors. The utility rates per kilowatt hour were a little cheaper than they are now. And we actually reduced our pumping cost to a range of $140 to $200 a day. So you can see right away that on a normal season where we would run that well 30 days, at least 30 days, especially when there was a second crop involved, that there was a $8,000 to $14,000 savings per well. That was quite substantial, and you could basically pay for a conversion from diesel to electric in 1 year at prices like that. So it was the decision to convert everything was a no-brainer, and it was a matter of not if you were going to convert, but how soon you could. Diesel prices moderated in 2009 to 10, but crept up again and peaked out in 13, 14. Next slide, please. I'm sorry, Lydia, go back to that other slide. Thank you. Today, even at $2 a gallon, there's still a savings that exists, especially when you consider the fact that you don't have to change engine oil and filter, fuel filters, air filters, regular maintenance on an engine, and a couple of mechanics trips. And also, you didn't have to worry. There was usually a fuel tank on that site that you probably needed a spill prevention plan on file for. The one good thing about electric motors is there's no emission from it at all. And it just makes perfect sense to run electric. The last couple of years, our average pumping bills have been between $50 and $60 an acre, which is very manageable for us. Next slide, please. I'm now going to change over to after the water hits the field from being pumped from electric-driven wells, where we can actually control the depth of the water using a very practical, a very inexpensive device that we developed years ago. And it's very simple. If you look at the water gauge in the middle, it was the one that we had originally designed, and it has a level range of 0 to 4 inches. After realizing that that even though it worked very well, it eventually needed maintenance. So we decided to go with a much simpler gauge, which you see on either side.
Fred, we're having a hard time hearing you. You're breaking up a little bit.
It gave us a range from 0 to 6 inches, and this gauge was actually the local in Bearfield.
Fred, I think we lost you there for a second.
No longer see the water because of the taller ice. The gauge will let you know at a glimpse how much water is in the cut. I'm sorry.
Sorry, Fred, you keep cutting out just a little bit.
I'm sorry. Hopefully I don't have a bad connection, but there's no way I can tell.
We can hear you okay now. So
The water gauge will also make. Okay, thank you. The water gauge will also make you aware of any problem that you have with water in the field. And if you notice, if you take a real good look at it, the gauge is marked with reflective tape, which allows you to ride by and check the water even at night. And checking water at night is a frequent occurrence during our busy season. The reason that I brought this up is just we make hundreds of these and put them out in the field. And once you get them, we use the minimal amount of water that we need. We know exactly, basically to the inch, how much water is in the field. So we don't overfill. We don't leave areas without water. It's just a simple no-brainer as far as for making it easier and reliable to know exactly. And since rice is a water-loving crop and needs water, we keep everything flooded, but we don't like to use too much water because, of course, that costs money and it takes from our natural resources. Next slide, please. I'm now going to focus a few minutes on the energy that we use to dry our rice crop, that being natural gas and electricity. Next slide, please. In 2014, we invested in a grain management system to dry green rice and properly store the dry rice. Next slide, please. Basically, it's a system of cables oriented in a bin to monitor grain temperature, relative humidity, and equilibrium moisture content during the drying process. And if you look at the picture, you can see the photo of the bin, and it's got some blue dots in it, and that basically shows the cables are positioned in a circular grid with one cable in the center. So, next slide, please. I actually took a picture a couple of days of some of the Clearfield jasmine that we still have in the bin. This is actually a 48-foot bin, and you can't tell, but it's got 6 cables in it. Next slide, please. Next slide, please. All of the cables measure grain temperature, and 2 of the cables also measure grain temperature, grain moisture, and relative humidity. And you can see on the picture on the right-hand side, the actual sensors on the moisture sensors on the cable. They're at 4-foot intervals in the bin, and the first sensor starts about 2 feet off of the floor. Next slide, please. The parameter set for drying can be monitored and changed on the desktop, on the farm, or from any device using one of a few utility apps. We're usually more aggressive when we begin to dry and narrow the parameters as the grain begins to dry. And depending on the humidity of the ambient air, natural gas can be used to achieve the desired desired target EMC. I also like to keep the air in the plenum going through the grain at no more than 20 degrees Fahrenheit above the ambient air temperature. Next slide, please. In this photo, you can see the actual readings from the cables from left to right are temperature, relative humidity, and moisture content. This system has allowed us to dry rice as efficiently as we can. Of course, that efficiency is dictated by the environment that Mother Nature provides when we're drying the rice. But being able to take control of the parameters takes all of the guesswork out of drying. And if you happen to over dry the bottom of the bin, you can adjust the parameters by actually rehydrating the rice and blowing higher moisture grain air through the rice. Addition of this grain management system has basically increased our capacity in the bins by 15 to 20%. Before we had this, we had mechanical stir-alls in the bins, which didn't allow for us to fill the bins up. Now we can basically fill them up to their capacity. So it was basically like putting up two more 48-foot bins with just the addition of this system. I also like the fact that after the rice is dry, the system can cool the rice down if the ambient air temps and humidities cooperate. And a good thing about it, the system will only cool if the target EMC is achieved and the plenum temps are lower than the average grain. In other words, it never blows warmer air back into the, it reads the grain temperature, and if the ambient air is higher than the grain temperature, it won't cool until it goes below that. Ever since we've invested in this system, our milling yields have been consistently better with this system. And of course, that was one of our main objectives when we invested in the system, was to achieve milling yields, because as everybody knows, that's the basis on which you're paid for your product. We're also very satisfied with the drying cost involved. On an average, it costs us 60 cents a barrel to dry our crop. That's 37 cents a hundred, or 17 cents a bushel. And a lot of that depends on the power company that you have supplying the electricity to you on rate changes and stuff like that. So that's basically all I have today. I want to thank Lydia, USA Rice, and the American Society of Agronomy for having me. Thank you.
Thanks so much, Fred. It was very interesting. I think so next we'll turn to AJ Hood. He's a farmer in Tiller, Arkansas. AJ is going to talk a little bit specifically about solar power.
All right, thank you for having me this morning. I guess I want to start my discussion about, how I got, because as everybody knows, we're skeptical as farmers. Anything new, anything not seen. So solar was not common in my area 2 years ago. When I first was approached about the farm, I had nothing to compare it to. So it took a lot of soul search, a lot of looking over data, looking over expenditures, seeing where my returns were with solar. By doing that, I figured out very quickly that it did make economical sense to implement it. When we started looking at it, I felt like it was the right direction to go, because as producers, we're always looking for that next step as well, as in marketing wise. We want to produce a crop that our consumer wants to buy, and sustainability is key to that. So we did the same thing Mr. Fred did back 6 years ago. we implemented the automation system on that particular bin system you see there in the background. So, like you said, we were maximizing our efficiency to the best we could. So when the solar came along, all it did was it was just that next step in our operation. We pride ourselves in trying to be proactive and trying to find that next step, and it really just just kind of turned into that situation for us. It really, we're looking at it as a marketing tool as well as, what we're doing from the environment. As a lot of times as a producer, as a farmer, the general public doesn't see what we're doing on a daily basis. They don't see, how we're, taking that water savings like Mr. Fred was talking about. They don't see, the scouting, the research, all that goes into farming, and with something that's highly visible. As you can see, right to the left of that solar farm, all that traffic going down the highway, that's a major highway for our area. So everybody going to the beach at Florida gets to drive by there and see it. And then I get questions all over. And I love having that. I love that interaction and talking to people about it and why. And I got the opportunity, after doing this, I got the opportunity to invest in a company, Delta Sun Energy, that implements for farmers, because I understood what a farmer's need was. But going aside from that, I think it is the future. I've been quoted several times. It's as practical on a farm as a tractor. I really do. I see it as I see it as the future, and with farming, it's always multi-generational. My parents, grandparents farmed, and that's the way it is on the farm. Where something like this, when you invest, it's kind of like investing in that grain facility. You do it for multiple generations. So that solar farm there, the panels are completely warranted for 25 years, and that farm is going to be there. That solar farm is probably going to be there for 60 plus years. So it really adds benefit not only to the farm, but it adds benefit to multiple generations to come. So I think it does a lot for our industry, and it does a lot for the way like I said, the way the consumer sees us as the farmer. I really enjoy being able to talk to other growers about it and how it works and why it works. And, because as growers, we love bouncing ideas off of each other and out what's working for you, can I implement it on my farm? And that to me has been very rewarding and very just something that I can hang my hat on and say, look, this is what I'm doing, because, everywhere I go, everybody wants to ask me about it, and being able to talk to them knowledgeable about how it works is, it's just been exciting for me. That facility there, that takes care of all the needs for that particular grain facility. When analysis is done, we made sure to match the solar farm to the grain facility. You don't want to overproduce. You want to produce exactly what your operation, and that's what we did, and to maximize everything. And there's so many tax benefits that go along with it. It makes it really feasible for the farmer. So, is it something for every farm? I would say probably 99% of the farms. It depends on your state and your state laws. Arkansas has favorable solar laws currently. Some other states do not have as favorable solar laws. But, I would encourage people to go out, look, research to see, is it favorable in your state or not? You want to hit the next slide, Ms. Lydia? See this farm, it's approximately over an acre, just a little bit. And the only reason it is because I wanted to space it out where I can maintain it properly and keep it clean and making it look nice. And you see down there on the bottom, my estimated annual savings is going to be approximately $27,000 a year. I don't make on any other commodity I grow, so it's really, I think, really beneficial to our farm just to be able to say we can do that on an acre of property. Why don't we slide? Can we go to the next slide, please? Oh, there we go. Here's another, local in the area implemented as well. And another one is, what, can we go back to okay, this producer here, his is about 110 kW larger than my particular system. This system net meters for agriculture wells, where in Arkansas we're really favorable, like I said, for solar laws. It allows you to build this solar system in one particular place. It goes through a bin, and then it is, or goes through a meter, excuse me. It goes through a meter and is used to aggregate all over the farm. So this one solar farm is running approximately 20 different wells. And everybody asks, well, how does that work? Well, it's pretty simple. It's just like putting money in the bank. So when you build a solar farm, you're just taking money and basically putting it in the bank. We use wells approximately 3 months out of the year. Well, the rest of the year, they're just sitting idle. Well, to have this is you're banking crap that year, constantly banking credit. So then when you turn those wells on come June, you have those credits and you're able to your bills. So it really been do it that way, because if we weren't able to aggregate and do the net metering, that system would have to be 4 times larger than what it is to the power to run those wells, and it wouldn't be economically feasible to do that. So this doesn't apply to every state. Like I said, it's their own different laws regulated by their different public service committees. So I would encourage anybody that's interested to just research that full time and just see how it could be beneficial. Can we go to the next slide, please? I put this one on there as well. This is a local producer. It doesn't have to be on the ground. He utilized roof space. He has approximately an acre of roof on top of that shop. So he didn't want to put his on. So he's got a 150 kW system right there on top of his shop. So he's generating approximately $20,000 a year just from the roof of his shop, where he never has to look at it. He never has to mow around it. Nothing. It's just there producing power year round. So that's very I guess utilize it. It's very good to utilize that space and have it there for that opportunity. The next slide. And here's another producer. You can see, utilizing space that's not previously utilized is what I like about it, because we all have space on the farm that we're just not doing anything with. We have a piece of ground, a grain bin, a piece of ground around, a field or a well or something that, we can't farm, we can't utilize. So this allows us to take that ground and be able to utilize to make it, instead of being in production, have it in solar production and generating electricity and really make something of value out of that. So I really think that that's key to the whole thing. I mean, not only are you able to get so much tax credits, you're able to get so much benefit with the consumer seeing it able to be marketable and as a whole. But all of that's great, but being able to utilize a piece of property that you couldn't previously utilize is extremely beneficial to us and our operation. I think another misconception is everybody wants to know, well, you have to have all these bats and you have to have different ways to make it work. Well, that's a misconception. Like I said, here in Arkansas, you're able to use net metering and aggregate. So all that power goes into one meter and it's put on the grid system to bank those credits. Where yes, I feel like in the future that's going to be there and be implemented. But as of right now, the cost of batteries, don't make economical sense. So, but that time is coming. 5 years ago, solar made economical sense in Arkansas. It did on the West Coast, where their rate of power or their purchase rate was a lot higher than it is now. Well, over the past 5 years, the cost of solar has dropped approximately 50%, which made it economically feasible here in Arkansas to utilize. So I really hope it keeps going and it's something producers can really utilize on their farm while the technology is here and while we're able to adapt. So I guess I'll be here to answer questions at the end. I kind of got short and sweet. So if there's anything else, Lydia, I appreciate everybody listening and the opportunity just to talk a little bit about my operation and some of the ones locally.
Thanks so much, AJ. Now we're going to move to Chris Crutchfield to talk a little bit about efficiencies at the mill.
Okay, hello everyone. Thank you for having me today. I want to first start out by thanking our hosts, the American Society of Agronomy, the USA Rice Foundation, and of course NRCS from USDA. Thank you very much for having me here to talk a little bit today about what we do after the farm. The rice leaves the farm. We've heard both from Fred and from AJ a lot about what can be done on the farm to conserve and save energy and reduce emissions, and that's fantastic, and that's what a lot of people think about when they consume food, is what the producers of that food are doing to save on energy and reduce their consumption and emissions. But a lot of what goes on happens between the time the consumers buy the food at the grocery store and the time that it's produced on the farm, and that's in the processing of it. And rice is no different, even though it's not a ready-to-eat product on the consumer shelf. So what I want to talk to you today about is after the rice leaves the farm, what does drying and storage managers and millers, packagers and marketers, what we can do to also reduce energy consumption and emissions. Next slide, please. So first of all, a little bit about American Commodity Company, which has become known as ACC Rice over the past 20 years in the industry. We're a family-owned operation that's vertically integrated into all aspects of rice production and marketing. We have a seeding operation that helps farmers evaluate what kind of rates they should be using in the application in their fields, and we soak and sell seed here at ACC Rice. We also have a rice production component to our operation, both as a company and independently as our three-family ownership group. We operate large-scale commercial rice drying and storage facilities, 5 of them placed strategically throughout the about 100 square mile rice producing region here in California. Of course, transportation is a big portion of what we do here, as we are involved in a lot of the rice leaving our facility here at the mill. Of course, we're milling rice, and then one of the components that we've added on to our operation in about the last dozen years is an energy generation component. Next slide, please. So the first thing that I want to mention that's on topic and a little bit off as well is that one of the great things about rice is everything that the farmer brings to us from the field is used. There is no byproduct, so to speak, that has to be disposed of. The hulls on the rice have two primary uses. They can be used as poultry bedding, or they can be incinerated into bioenergy generation. The bran has numerous different components. It's very rich in protein and can be used anything from extracting the protein for health foods. You can make bran oil for cooking. It's also widely used in all kinds of pet and animal feed. And then, of course, you have the rice itself. Whole kernel rice, we all know we cook and eat that every day. And then broken kernel rice is used in all kind of ingredients, everything from flour to cereal to alcoholic beverages, and really everything in between. So again, like I mentioned, everything that the farmer brings us here at the mill, we use, and we're not wasting anything. Next slide, please. So today what I'm going to talk about is energy production at ACC. And then I'm going to talk about energy consumption and our ultimate goal of making those two either zero out or get on the actual energy consumption negative side of the bar, if possible. And then I'm going to also talk a little bit about energy consumption after ACC and what we're doing after the rice leaves our mill in an effort to continue to reduce emissions and reduce energy consumption. Next slide, please. So first, the energy production portion of this. You've heard from AJ a lot about solar. We have several fixtures that we began our foray into solar energy production in 2004 as an ownership group independently of the corporate structure of ACC Rice. We started out by putting them independently on our farms, and then aggregating them into our drying and storage facilities. That resulted in several different small operations aggregating to about 1.8 megawatts worth of energy. And then in about 12 years ago, we built our first large scale solar farm here in Williams in Northern California, right on our 89 acre footprint at our main site. And that's an 11 acre solar array that's producing a little over 1 megawatt of electricity. And recently in the summer and fall of 2019, we came on the grid with a 6 acre solar array at our Willows facility. So combined, we're generating about 1.75 megawatts of electricity. And that's an amount that greatly exceeds our use at those two sites of drying and storage, and actually makes a contribution to our milling and packaging operation here at the main site in Willows. The energy production, backing up a little bit, in California is, as most things are in our state here, very highly regulated and much more complicated than many other places in the United States. Pacific Gas and Electric, PG&E, controls basically the whole grid in the state, and you have to work out an agreement, a power purchase agreement with PG&E to be able to run solar and any other kind of energy production for that matter. So what you have to do is, much like AJ talked about putting in the bank, once you hook up, you put power up into the grid at a rate of whatever your production is. And then, of course, you're pulling power off the grid at whatever your usage rate is. The complex thing about that is the regulatory side of it. The nice thing about it is you don't have to use and consume the energy at the same time or at the same rates. In other words, in the summer, here in California, there are times when we have as much as 16 hours or more of daylight. And of course, those times are not equal to the times that we're using the most amount of power, which would be during the harvest season. So we're able to essentially sell that power to PG&E when we're producing it the most, and then buy it back from them at the time when we need it most. So that's a highly efficient, although regulatory complex method of energy production and consumption here in this state. The last two facilities that we've put in are obviously technologically the most efficient. They're on automated actuators that can follow the sun from the time it pokes over the coastal range in the morning till the time that it, from the Sierras in the morning till the time that it sets behind the coastal range in the afternoon. And that's a highly valuable tool, especially during the summertime when we have all the daylight, all the sunlight hours. And again, basically here in Northern California in the Sacramento Valley, from the 15th of April to the 15th of October, every day is sunshine and we don't get any rain. So that's a highly, highly productive time period of the season. And it's really nice to have those actuators that can follow the sun year round. Next slide, please. Okay, I mentioned the rice hulls have two main uses. We at ACC, we don't use our rice hulls for the poultry bedding factor, but instead we have chosen to use them as bioenergy. In the 1980s, there was a large construction of a large bioenergy plant right in the middle of the four major rice mills, and then later a fifth was built. So we now have 5 major rice mills within about a 20-mile area here along the Interstate 5. And they built this facility right in the middle of those and had contracts with each mill to deliver the hulls to them for incineration and energy generation. So the scenario 1 on the left of your screen there has the 5 rice mills delivering the rice hulls to one central burner and CHP unit, and then that energy is generated back up to the grid, much like I talked about earlier from the solar, and the heat is generated from that is used at that facility, and then rice husk ash, which is used mainly for incorporation into soil to make the soil more fertile. Scenario 2 is what we're working on right now. We're working on a agreement with PG&E where we would be able to construct an on-site facility where we would not have to truck our hulls to the centralized facility, but we would be able to essentially convey them right off of the rice mill into the on-site CHP unit, and then we would be able to generate the exact same electricity, heat, and rice husk ash that the major commercial facility is, but all of it would be right here on site. Right now, the hulls that we send to the centralized unit are being used to generate about 2.8 megawatts of energy. And our ultimate goal is to come online in 2021 with the on-site facility that has an output goal of 3.5 or more megawatts. One of the other, in addition to increasing the amount of electricity produced, just basically because of the on-site nature of it, no loss in transportation, as well as technological advances over the last 25 years in the biomass field. Another great advantage of this is that we estimate that we're going to save more than 11,000 gallons of diesel every year, and all of the carbon emissions that go along with trucking rice hulls every day, 360 days a year, down to the centralized facility. Okay, next slide, please. So that's a little bit about energy production here at ACC, and now I'd like to talk a little bit about energy consumption and what we're doing to increase our efficiency in that. We've committed to being part of a landfill solution by diverting all the recyclables 3 years ago from our solid waste stream, and we're doing this all on site. So we have basically our own recycling facility right here on site in Williams. And we estimate that we've reduced our landfill contribution by more than 90% and saving more than 5,000 gallons of diesel every year by staying on site instead of hauling this off. In addition to that, we have noticed that rather than coming by to pick up our solid waste once every week, we've put in a compacting system that the county's only coming by about once every 2.5 months now to pick up our solid waste. So that's a great deal there, and it's not only saving the landfills, but it's also again that's saving diesel consumption and emissions production. We went through our entire facilities, both facilities in Williams and in Willows, and replaced our high bay metal halide lighting fixtures with energy efficient LED and natural light. So the natural light was something that was actually a suggestion from our employee suggestion box. And so we put in a bunch of skylights on top of the mill and packaging and storage facility, finished dry storage facility. So the folks that work during the day shift, they're not working under artificial light, they're working under all natural light. And that was a great suggestion by one of our employees, and of course saved us a lot of money and a tremendous amount of energy consumption. Another thing that I'd like to mention that's not anything that we've done here at ACC, but that we're seeing as a trend throughout most of the westernized world as a consuming healthy products becomes more and more the trend. There's a lot more consumption of brown rice, and what we're seeing there is that we're consuming a lot less energy when we mill rice to brown instead of to white. We use about half of the equipment, and because we don't need to run our whiteners at all, we just need to run our huskers. Just take the husk off of the rice and then send it out as brown. So you can see there that milling rice to brown from white has about a 3,000 kilowatt hour daily savings. So that's a real trend. When you go to buy brown rice and consume that instead of white, you're not only eating a healthier food product, you're also saving on energy consumption at the processing facilities. And finally, again, a little bit off topic of energy consumption, but one of the other things that we've switched to is all of our paper bags are produced from post-consumable goods. We buy them from a supplier that's part of the Sustainable Forestry Initiative, and they're using a certified forest to obtain their fiber. Next slide, please. Okay, now a little bit about energy consumption after ACC. So transportation is one of the major productions of greenhouse gas emissions. Almost 30% are generated through the transportation sector, and 90% of that fuel used for transportation is petroleum based, which includes primarily diesel and gas. So we've tried to do something to address that after the rice leaves our facility here at ACC. So next slide, please. We've transitioned a lot of our distributors that are based all over the United States from truck delivery or over-the-road delivery to delivery by train. So we have a facility here in Roseville, which is about 45 miles from our rice mill, that we can truck the rice to, and then with a crane take the container off of the truck and put it on a train and move it to by rail to other facilities where our distributors can pick it up. And you know, on average, trains are 4 times more fuel efficient than trucks. They can carry more freight at the same time, thus be more efficient, and they're actually a major freight savings for long distances. They emit 60 to 75% fewer GHGs than equivalent trucking. So the fact that we've been able to switch that over is a big help. Next slide, please. One other one that we're using is for our break bulk rice shipments that mainly go to Asia. We're shipping them out of the Port of Stockton, which has converted all of their heavy lift forklifts from diesel and gas to electric forklifts that are charged there on site, much like a Tesla charging station, if you will. Okay, so I'm sorry I went a little bit long on that, but a lot of information to cover there, and that wraps it up for me. Thank you very much.
Thank you so much, Chris. So now we're going to turn to Carl Kaiser from AgriLetric.
Hi, and thank you for giving me the opportunity to share a story about AgriLetric Power. This will be a brief and general overview. I'm going to skim through these slides, not to bore you with the details, but to give you a feel for what we do and how we do it, and hopefully leave time for questions and answers. If you'd like more information on any of these topics, my contact information will be at the end of these slides. So let's start with who is AgriLetric. AgriLetric is a part of a very diverse group. The parent company, the Powell Group, located in Baton Rouge, consists of multiple companies. On this slide, I've listed the direct relationship to AgriLetric. The Lake Charles complex consists of a land company, farmer's rice mill that is located adjacent to AgriLetric, AgriLetric Power, which receives the rice mill's byproduct and converts the rice hulls to electrical energy, and then finally AgriLetric Research, which processes and packages the rice hull ash, or what we refer to as RHA. The rice hull, probably the rice mill's favorite topic. What AgriLetric examines is the BTU value and chemical composition and the various rice hulls from around the world. And we found that no matter what variety of rice or the region of the world, rice hulls are typically the same. We do notice some deviations in some elements such as potassium content, which we feel is an uptake from the soil or additional amounts of fertilizer that the farmers apply. The bottom right photo is a cross-sectional view of the rice hull, which plays an important role in what we do with our byproducts. I'll touch base on that a little bit later. A brief history of AgriLetric. The facility was the first commercial operations to generate electricity fueled entirely on rice hulls. The plant consumes around 117,000 tons of hulls annually. We supply the complex with energy needs and export the remaining power to the public grid. Differing from other forms of biomass facilities or wind and solar, rice hulls are generally available throughout the year, which enables the power plant to run roughly 350 days a year and 24 hours a day. This slide illustrates the general overview of the process. There are many different techniques that combust rice hulls. Each method will have an influence on the RHA quality. The combustion process at Lake Charles facility is like a coal power plant, where the rice hulls are ground to a certain specification that permits the rice hulls to burn in suspension. This is probably not the cheapest method of combustion, but it allows controls that influence the RHA value. For over 35 years, marketability of the RHA has been in the forefront of our priorities. Our on-site laboratory continuously provides feedback to the plant operations, which in turn will adjust the process conditions. Just a quick timeline reference for the Lake Charles facility. Between 1982 and 1984, AgriElectric was a paper napkin discussion, which resulted in the base model today. After 26 years of operation and high maintenance expenses and a new power purchase agreement, the facility was refurbished in 2012. Although the facility has generated renewable power since 1984, to be considered green or Green E eligible, we were required to basically rebuild the plant to a near new status. This is a topic we share with groups that contemplate installing a facility to combust rice hulls. The model for the Lake Charles complex arrangement consists of the rice mill adjacent to the power plant and the packaging facility on site. If any of these entities were separated, freight cost and handling would be a negative component of the operational expenses. And another beneficial factor is electrical supply produced from AgriElectric's generator. It supplies the rice mill, AgriElectric Research's packaging facility, and the public utility. As you can see, the red line for the power distribution, if there's an electrical supply disruption from the utility or AgriElectric's generator, the interruption is usually not detected at the rice mill or packaging facility. Anyone that runs a rice mill knows the consequences of abrupt electrical outage, not only safety reasons, but for choking of the equipment. The title for this slide is a little misleading. We feel like we have a positive influence on the environment. Rice mills know that the milling byproducts are seasonal commodities and sometimes difficult to move. I haven't yet met a rice miller that loves rice hulls. Since the beginning of AgriElectric, the Lake Charles facility has consumed over 4 million tons. Environmental studies indicate that methane gas is generated from organic landfill types and is one of the main contributors to the greenhouse gases. AgriElectric has eliminated many tons of rice hulls that would have otherwise been landfilled. A couple other points on the slide is that we have a team that is continuously developing products for the RHA markets. We utilize Louisiana rainfall of 60 inches a year for cooling and do not tap into an aquifer for cooling purposes. You'll notice in a photo, a 23-acre cooling pond that utilizes the surface area for evaporation cooling. Energy efficiency. Our goals are to consume less power and help the bottom line. Although we're a small energy producer, we continue to evaluate waste energy in dollars. As mentioned earlier, we refurbished the facility to continue to run another 28 years, but also to increase our rated output and efficiencies. Since then, we've run record rates with minimum downtime. We've replaced old control systems with variable frequency drives. We've converted some of the electrical motors with steam-driven energy. We also discovered equipment that was running, when not needed. Besides training and procedures, automatic shutdowns or alarms were implemented in these cases. Lastly, the preventative and predictive maintenance practices. We found sound justification that proves a good program will have an ROI. Here we get into the byproduct side of the business. I'm not going to get too detailed in this subject, but wanted to highlight that our efforts don't stop at making renewable energy. As you may have noticed the internal structure of the rice hull photo at the beginning of the presentation, when combusted in a controlled environment, what you have remaining is roughly 93% amorphous silica and a 4 to 6% carbon. The photo to the right is a skeletal structure remaining after combustion. The high surface area and non-detect crystalline silica makes the silica unique in certain uses. Listed at the bottom are some of the applications. In this slide, the processed RHA is used as a filter aid in solid liquid separations, meaning that the RHA will capture impurities and produce clear solutions, not only water, but oil clarification purposes. Project development continues to refine the RHA silica into silicates, such as sodium and potassium, which could further be processed in precipitated silicas. The photo to the right was a product development effort when a customer needed to clean their wastewater prior to discharge and meet EPA requirements. You'll notice the clarification progress when the dirty liquid is run through one of our products as it progressively gets better. That sums up the agriculture portion of the presentation. I know I breezed over these topics. If you'd like more information about the power plant or some information on the RHA products, please feel free to give me a call or just email. All my contact information is sitting here posted. So thank you for your time.
Great. Thank you so much, Carl. I think we've got running a little over time, but I think we maybe have time for a couple of questions from the audience. Chris Boomsma, do you see any, are there any audience questions currently?
We do have a few, but I think the ones that you had prepped might be a better option for this time. So why don't you just take a couple minutes here, the 4 minutes that remain before we go to 10 after, and ask some of those key questions that we had discussed.
Sure. So I'll start with Fred and AJ. Is there something that you wish you'd known before you started the projects that you talked about today? Is there advice that you have for someone that's looking to get started on it?
Go ahead, AJ.
Go ahead. I'll take it through.
You know, anytime you make investments that are going to better your bottom line, I think the biggest question I have is why didn't we do it sooner? And a lot of times, you know, converting these water wells to electricity, this grain management system, you know, you just wish you'd have taken advantage of the technology sooner. I do have to say that I'm very impressed with the other presentations, and solar energy has got me thinking. So I appreciate it. Thank you.
I'll throw out another one.
I think Brad took the words right out of my mouth.
No, go ahead, AJ. Sorry.
I think he said the same thing that I was going to say. I wish I would have been so skeptical in the beginning, or implemented a little bit sooner, because, you know, it works. And I wish I would have known that and not been so, like I said, skeptical or standoffish just because it wasn't in my area. Now, it is all over the country, but it's not in my area. So I think that's the biggest thing to me.
So this is one that anybody could answer. Several of you touched on kind of what, you know, on some of the solar projects, them being more visible to the community, starts conversations and things like that. What have you guys seen in some of the projects that you worked on around energy efficiency and sustainability, about how the community has reacted to it, or some of the interesting conversations that you've had with different people in your community because of some of the projects you're working on?
Well, this is Chris. I'll jump in and answer this one first. Out here in California, under our regulatory environment that we live in, it's pretty drastic. But both on the farm and after the farm, the rice industry, led by the Rice Commission out here, has done a real great job of proactively going to the decision makers and the regulators and elected state officials and showing them what our farmers and our millers and our dryers are doing out here in California on a proactive basis, not in reaction to regulations. And I think has led to the rice industry, at least in this state, which is one of a lot of agriculture, as being viewed as the most environmentally friendly crop in the state, and has allowed us to do a lot of self-regulation, where a lot of the other crops that are produced are always reacting to being regulated. And so within our community, I think the entire state recognizes the rice industry as a real forefront in both sustainability and energy efficiency.
Absolutely. Do we have any audience questions that we want to maybe do one of those before we wrap up, Chris?
Yeah, mostly it's comments thanking the speakers for their great presentations and what they're working on. That's the majority of what I got today. And actually, we're probably pretty much out of time at this point, unfortunately. So we're going to have to wrap it up, Lydia. So thank you, though, to each of our presenters, Fred, AJ, Chris, Carl. Thank you, Lydia, for moderating today. I do appreciate that. For everyone out there, thank you for joining. Please be on the lookout for future webinars from the American Society of Agronomy, including potential future webinars from the Rice Foundation. I think, Lydia, we have one more planned coming in the future here, if I'm not mistaken. So.
Yes, there's one more coming up in March, and the topic is to be announced in the coming week or two.
Yep. So thank you very much. And everyone out there, I hope you have a great day, a great week, and a great preparation for the spring season coming up. Take care. Bye-bye.
Thank you.
Thank you.
Thank you.